All right, so as we were doing this integral, we said that we wanted to close underneath the essential singularity instead of on top of the essential singularity. Let's do that computation slowly. Okay? So here's my essential singularity. Let's imagine going above that essential singularity and write out what that integral would give. Okay, I'm going from pi to 0. I've got e to the I over epsilon e to the it divided by epsilon squared e to the 2it minus 7I epsilon e to the it minus 12. And then dz becomes I epsilon e to the it dt. All right? Now, epsilon is going to 0. So in the denominator, we effectively just have negative 12. You might think that this epsilon would make the whole thing go to 0. However, you would be ignoring the epsilon in the exponent here. All right, so let's just write this out in the following way. I'm going to have I epsilon e to the it divided by stuff. This really doesn't matter. All right, and then the exponential. So it's going to be I over epsilon e to the minus it. Okay, so let's see what that is. E to the I over epsilon, e to the minus it is cosine t minus I sine t. So that's e to the I over epsilon cosine t times e to the 1 over epsilon sine t. And that's where the problem lies. As t goes from 0 to pi, the sine of t is positive. Epsilon is going to 0. So this integrand is going to go to infinity. Despite the fact that we're multiplying by epsilon, epsilon times e to the 1 over epsilon clearly does not go to 0 as epsilon goes to 0. I mean, think about it. What if epsilon was 0.01? So then it would be 0.01 times e to the 100th power. E to the 100th power is significantly larger than the reciprocal of 0.01. Okay? And that process gets worse and worse and worse as epsilon gets smaller and smaller and smaller. So if I close above, the problem is that the exponent, or the exponential, is going to positive infinity. All right? An easy way to think about that is just to look at this point right here. Okay? That's where z equals I epsilon. So I would have e to the I over I epsilon, e to the 1 over epsilon. Bad. Okay? What about if I went underneath instead? If I went underneath, then, thinking about it the easy way, you could also do the long way if you wanted to. But thinking about it the easy way, I over minus I epsilon, e to the minus 1 over epsilon. And that one's good. Now, this little semicircle integral is exponentially damped. All right, it also has a really small radius. Okay, so that allows us to pretty much trivially show that it goes to 0. And that's why we can close the contour below the essential singularity, but not above. Along the same lines, we would have, if I had, for example, e to the minus 2i over x, now I could close above, but not below. All right,